This video is based on a recording of a live event. It contains additional content to help the audience understand the context of the topic presented. If you wish to skip directly to the primary topic, see the timestamps in the video description.
Hello, everyone. My name is Andrii. I am a senior data scientist here at DataRobot. I'm based in Kyiv, Ukraine. I've been here for more than 3 years. Over that period of time, I was involved in the wide variety of projects. Today, I'd like to show you an AI accelerator for end-to-end demand forecasting workflow, which is based on my past experience in similar projects. So let me share my screen. Essentially, that workflow is based on Jupyter notebook, which leverages DataRobot Python SDK. And it covers the following steps: data ingestion into DataRobot, preliminary data overview, modeling, getting the insights from the models, deploying the recommended model, and making predictions based on previously deployed model. Actually, in order to run that AI accelerator, you need two additional files. One of them is drutils.py, and the file with datasets links. They are available within the same repo as that notebook. The drutils.py file contains helper functions, which will be used throughout that notebook. And for this workflow, DataRobot provided publicly available datasets for training, scoring, and calendar. They are available on DataRobot's S3 buckets, and you can upload it to your database, use locally, or just directly load to your DataRobot instance. In case you are using Snowflake, you can leverage that prepared helper function. And once you fill in all of those fields, you can upload the data to your Snowflake instance. So just let's take a look at what data we will consider today. The first dataset is a training dataset. It consists of 50 distinct series with weekly aggregation, and the period is more than 3 years. Also, it contains, actually, the target is just units counts of the products sold, and several additional aggregations for that particular week derived from the target, and as well as transaction sum and promotion indication whether those particular product was on promotion during that particular week. Also, we have price and several metadata columns as well. The next data set is for scoring purposes. It had the same structure, but it includes additional future dates, which were not used for modeling, and it will be used just for pure scoring purposes. And the last one is a calendar file. It consists of just of two columns. Is a date and event name. I'll describe that purpose of that calendar slightly later. So just in order to start, we make some basic imports, pandas, DataRobot live package, and that file with additional helper functions. In order to use DataRobot platform, you definitely need to connect to it. In order to do that, here's the links how to acquire DataRobot API key and the description how to make that connection. So yeah, the next steps actually we will get that data from in that case it's from Snowflake instance. It can be get from any other databases supported by DataRobot or from local files. Here we define useful variables, date column, series ID, and the target because we will use it throughout our notebook. The next step is to get the data to DataRobot instance. Here we can use the following snippets in order to create dedicated data sources and data sets. We will pull from Snowflake, our Snowflake instance, training data and calendar file. And just to check the data for consistency, we will download from DataRobot AI catalog the training data set to review. Actually, that helper functions provide additional functionality to check your data before modeling. For example, it is good practice to check whether the number of series over time, just to find out whether there are any discrepancies in that case. Here we just see that the number of series grows over time. The target distribution. So for demand forecasting, it's usual to have highly skewed data set with a long tail on the right. And just to investigate the overall target over time, just to check whether, visually check whether there are any gaps or inconsistencies in the data. Also, that helper functions provide additional data checks. For example, we can identify spikes and plot those series which have those spikes. Check for negative values. Usually it's okay, but so in some cases it's not expected to have sales below than zero. Checking for duplicated dates. It may indicate about data entry errors, and those instances should be investigated further. And also, the last but not least is gaps identification. Here, our data set is evenly spaced by week, but it's good practices to check whether your data doesn't have unexpected gaps. For example, when the store was closed or the product was out of stock, it's actually no feature, but when the store was working and the product was on sale, but that data is missing, it should be definitely fixed before modeling. So once we are happy with our data, we can define our modeling settings. Here is the link to the extensive documentation in the DataRobot. But today we will focus on several settings which are pretty essential for time series modeling. First of all, we will create our calendar. It will be created based on a data set which we created previously in the DataRobot AI catalog. Also, you can create it from the local file, or even DataRobot can generate it for you based on the country code, ICO country code, and the date ranges. Under the hood, DataRobot will add additional features based on that calendar file. For example, it will add features like days to the next event, or days since the last event. It will help your model to identify instances when your sales were unusual, for example, lower than usual or extremely high. Yeah. The next set of settings are features known in advance. For example, those are features which we know at the prediction time. Those features are definitely some metadata about store, about the product itself, but it can be also indication whether that particular product within particular store will be on promotion that week. Also, do not derive features. Actually, those features are you understand that there's no sense to derive additional legs or rolling stats based on that. One addition, the next feature I would like to mention is a segmented project. If false, the DataRobot will run actually standalone project with all of the features. And if it's true and the cluster ID will be specified, DataRobot will run under the hood a bunch of projects, one project per every cluster ID. And in that case, it will create feature list regarding that particular subset of data, and it may boost your model accuracy. Also, it will be beneficial for deployment purposes because it will be covered within one deployment, and DataRobot under the hood will decide what cluster use for particular predictions. So the next set of features of settings are actually feature derivation window. It's a pretty essential part in that case. Feature derivation window represents the rolling window that is used to derive time series features and lags. So its definition should be long enough to capture relevant trends to use case. But on the other hand, it shouldn't be too long because it will shorten your training data and it may generate additional redundant features. So it is advisable to iterate over several sets of feature derivation window start and end. As of the next setting gap duration, it's a duration of the gap between training and validation data, which actually represents reporting lags in real world. For example, previous week sales will be available only in next week, so we can't reuse the most recent data right immediately. The next is forecast window. It represents the rolling window of future values to predict, and it definitely depends on business application of the models of the particular use case. The next is number of backtest and actually validation duration. So proper backtest configuration helps evaluate the model's ability to generalize to the appropriate time periods. And the main consideration is the following: validation from all backtests combined should span the region of interest. So quite often that set of features like feature derivation window is subject to exploration, and it may depend on your needs and use case. And the last is actually the feature which allows DataRobot during autopilot to run additional blueprints which are designed for cold start. By default, DataRobot uses blueprints which are designed to predict, which are not designed to predict on new series or without long history. And that feature allows you to make possible to make predictions. Your deployment will be able to make predictions on series with little or even no history at all. So once we defined our parameters, we can pass it to that helper function along with the data. Data here is DataRobot dataset instance. It can be passed to the local file. It can be pandas data frame parameters, and that's pretty much it. Also, here we left those parameters: feature duration window, gap, forecast, window number, backtest blank. DataRobot will generate those values automatically. That function returns a dictionary which contains a dictionary with the projects and corresponding projects metadata. So once you run several experiments, you can combine them and store within that particular dictionary in order to iterate and check whether different project setups are more beneficial for your model performance. So once the model, the project actually finished, we can pull one of the projects and investigate the insights which the DataRobot provides. So here we have actually a helper function which can pull our leaderboard, which is also available on the UI. It represents every model and its performance on all backtest and the first backtest. So also those helper functions can provide you accuracy plot over time. It actually plots actual versus predictions. In that, by default, it plots those values for the first backtest. Stability actually it represents how model performs between different backtests. The next one is series insights. For that particular model, DataRobot provides per series results. For example, just metadata, number of rows, the start, the end date of series, and the model performance of that particular series as well. And feature impact. Feature impact here is based on permutation importance. And as you could see, DataRobot within defined feature derivation window generated a lot of features. The vast majority of them, of important features, are just derived from our target, which is called units. Those are just 8 weeks mean, minimum value, median, several lags. And the second most important is actually the indication of the promotion. So that's pretty much it about the model insights. And once we are happy with our model, we are ready to deploy, we can also utilize that additional helper functions, which is called make deployments. It takes a dictionary with the previously created projects and deploys one recommended by DataRobot model within DataRobot infrastructure. Actually, it containerizes all model artifacts and provides ready-to-use REST API to make predictions on. In case you don't want to make deployments for all projects, that's common. You can select a particular project of your interest and specify the model ID, specific model ID. What would you like to deploy? Or otherwise, if it will be blank, DataRobot will deploy the recommended model for deployment. So once we are done with our deployment, we can pursue to making predictions. So we also have that helper function which can be utilized to do so. It takes a dictionary with the deployments. And also it takes intake settings Here we actually taking data from our database, scoring data, but it can be replaced with local file, and the output settings here are created to write our predictions back to our database, and in that case, it will create that table if it's not exist in that database. That output settings also can be replaced with, for example, local file storage. And one additional setting is actually pass-through columns. We can specify additional columns which will be included to that table with predictions, and they will be taken from that scoring file. Yeah. Here's the example, actually, batch predictions on demand. Also, DataRobot supports recurring jobs. So that function will create a job, and intake and output settings are definitely the same, but we have an additional setting for schedule, and based on business needs, it may schedule a recurring job, which will take the data from your database, make predictions, and write them back. So that's pretty much it about deployments and making predictions. So let's get the predictions locally and investigate what structure is. So yeah, essentially we will create a data set from that table in database and download it locally for further investigation. So the table with prediction contains series ID, forecast point, and that's a date from which you are making predictions from. The date is actually date for which the predictions were made. Forecast distance, it's actually indication of period for which prediction was made, and prediction itself, deployment approval status, and additional columns which were specified as pass-through columns. So in short, this takes us through the core functionality of this AI accelerator, and it provides the building blocks for time series experimentation and production workflow. So you can iterate with different forecast feature derivation windows, testing strategies. So also that workflow can be used as a starting point instead of doing everything from scratch. Some parts of it with some minor changes may be embedded into your current workflow. That's all I had for today. I appreciate your attendance and thank you a lot.